Welcome to the lecture for T7, Technology Plugin 7 for the Mac. And this is an introduction to SQL. In this lecture, we'll go over the background of the SQL query language, and then we'll talk about the basic query structure. SQL is a language we use to extract information from our databases, from our relational databases. We'll also, in the next lecture, look at additional operations, set operations, and aggregation functions, as well as joins. So we'll touch on some of these in this lecture, some of these in the next lecture. So it was developed by a gentleman named E.F. Codd, who worked at IBM, and he did this to address the complexity that was in database systems in the 60s that caused a lot of errors and a lot of glitches. There was a lot of problems with things like utility bills or student registrations, and you would have to go and go meet with the registrar or go down to the public utility, and they would find that in fact it was a database problem. And that led IBM to look at how can we solve this particular problem. And E.F. Codd developed a simplified version of databases that was based on relational algebra. And it was called the System R project for the relational algebra that he was looking at applying. And it did simplify things. And it was introduced in the 70s and then became very widespread in the 80s. And it basically took over the database world and was the dominant database for 30 years. In the early 2000s, the internet and e-commerce introduced a global demand. So instead of having tens of thousands of concurrent users, you might have millions of concurrent users. And the way that the relational databases are configured today, they cannot scale to that size. And so NoSQL databases started coming into being in the early 2000s, and they've gained traction in places where you don't necessarily need consistency of your records between different locations immediately. Eventually they will become consistent, but they don't have to be consistent immediately. The relational databases are still a very strong use case for them, and that's where you do need immediate consistency between your databases at all locations. So several standards came about, SQL 86, and then the prominent one used by most vendors is SQL 92. Some of the early vendors like Microsoft and Oracle, IBM, their databases were widespread, and customers invested billions of dollars in programming applications against those databases before some of the more comprehensive SQL standards were published. So rather than cause their customers a lot of pain having to go back and rewrite and suffer bugs and problems with the rewrite of this enormous investment they have in Microsoft, Oracle, and DB2 from IBM, for example, these vendors comply with most of those standard features, but some of them, in other words, they develop solutions towards some functions that were not addressed in earlier versions of SQL, of the SQL standard. And so rather than have their customers suffer a lot of pain, what they do is they still maintain their unique versions. So probably 90% of SQL will work on all of the various mainline systems, Oracle, Microsoft SQL Server, IBM DB2, Oracle MySQL, SQLite, which is a open source database, and that we'll be using in this particular course. And by the way, SQLite does come pre-installed on your Mac, so you don't have to install it. Now, in addition to the standard features, there are also unique features that each vendor puts in. And this allows them to offer administrative capabilities as well as an extension to the capabilities of SQL. So a database schema is your roadmap to accessing data in a database. And it's a logical group of database objects that are related to each other. So in SQLite 3, again, this is part of some of those unique extensions, they have what are known as dot operators. So dot tables is a command in SQLite 3 that will let us see the tables that are in our particular database. Once we've done that, we can then use the dot schema and a particular table name, like let's say student, and then it'll tell us the fields in that particular table and the data types of those fields in that particular table. And there's other dot commands that we would use dot quit to exit a SQLite database, and then dot open to open a particular database. So we'll take a look at SQLite. We'll have a number of demos in this lecture. So here you see I have SQLite. I'm going to just type in SQLite 3 space univ.db. So SQLite 3 is my program. It's the database engine. And univ.db is my database. So I hit enter. And now I'm in SQLite. So now I can use some of those dot commands. So for example, I type in dot tables, and I see a list of tables in the university database. And let's say I want to look at the structure or schema of the student table. Well, I would type in dot schema, S-T-U-D-E-N-T. And here is the structure. You can see I've got an ID field, a name field, a department name field, and a total credits field. And it gives the data types and tells me there's a primary key associated with it and a foreign key that references another table, department. Well, let's say I want to take a look at the structure of that department table. So I just type in .schema department. And here I get the structure of that one. Now, I can use the .quit to get out of this particular database. I'll use .quit. And now I'm back to the operating system. Now, in addition to putting the database name next to the program when I fire up SQLite, I can just fire up SQLite alone, like this, SQLite 3, hit enter. And you'll notice that it gives me a little notification that I'm using an in-memory database. These are extremely fast, and it's one of the reasons that SQLite is the most popular database, most widely used database in the world. But you can also then open a permanent or persistent database. So we could go .open univ.db, and now we're back with our original university database, and I can go .tables and see all the various tables in the database. There's also a .help command, and that gives you a listing of the wide variety of dot operators that you can use in SQLite. Okay, and I'll use one of them, .shell, to clear the screen. So, I mentioned that a schema is a roadmap that lets us just look at the data in the entire database and decide how we might get the information we're interested in. So, for example, it shows us the fields in the student table, the fields in the instructor table, and these arrows indicate that, hey, there's a relationship between student and department. A student's major belongs to one department. Likewise, an instructor is assigned to one department. And a student takes course sections, and a course section is associated with a course. An instructor teaches a section, and of course, again, a section is associated with a course. So the arrows show you how the various tables are related to one another. And if we wanted to get information on a student and the department they're in, we would be able to get that from two tables, student and department. And we'll be dealing with that type of operation in Tech Plugin T8 when we deal and talk about joins. This particular Tech Plugin T7, we're just going to be dealing with getting data out of one table and learning the fundamentals of the SQL select command, and then we'll extend that select command capability in T8. So here we are. The select command is what we use to get information out of a database. So the select command is going to have a form, select list of column names for your table or field names. And remember, we got those by looking at the .schema command in SQLite, or we could get those from this type of diagram. So the field names or the column names in the student table are ID, name, department name, and total credits. Now, if you don't want to list all of the column names, you can use a wildcard character, the asterisk, and that says give me all of the columns. I want all of the columns from that particular table. Pardon me, I'll turn that off. Okay, so here's the basic structure of the select statement. The typical select statement is going to have the form of select, a list of columns or fields, and of course in relational algebra, the field or column is called an attribute. An attribute is a characteristic of a particular entity that we're interested in. And then you have the next part of the select statement is from, and the R's there represent relations, and that's also known as a table. So the relations and tables are the same thing. So a relational database is a tabular database, and therefore it's very similar to an Excel worksheet, which is tabular. An Excel worksheet has a set of rows that indicate particular records and a set of columns that represent particular fields. And then P, where you have the where P. So the where is another important part of the select statement, and that's where we can specify conditions. We don't necessarily want all the rows in a table. We want the rows that meet the conditions that we have for a particular problem. And so P is a predicate, also known as a condition, that filters the records in our result set. Now when we do a select statement, and we can select from several tables. Right now we're just going to be in T7 selecting from one table, but in T8 we'll be actually selecting from multiple tables. But no matter the result of a SQL query like this, select from where, is going to be a table. It's going to return to you a table. Now it's a temporary table. It doesn't persist in your database like the tables that you start with. But nonetheless, it can be treated as if it were a table. So, a query is something we formulate, and it's a statement for requesting data to be retrieved from our database. Again, SQL uses one or more tables, and it returns one table. It's a temporary table. It doesn't persist, but it is a table nonetheless. The select clause that we use lists the attributes or fields, attributes are also known as fields, that are desired in the result of the query. SQL allows duplicates in relations as well as in query results. So if we want to get rid of duplicates, like let's say we say select department name from student. Well, we'll have the same department name, College of Business, for example, or music, or psychology. The same department would be repeated for each one of the students who had that major. So if we don't want to see all those repetitions, we can use the word distinct. So to find all the departments from the instructor table and not show all the duplicates, we would say select distinct department name from instructor. If we wanted all of the names, we would just say select department name from instructor, and we get the duplicates. So an asterisk in the select clause, again, tells the SQL database that you want all of the columns or all of the fields in the table. So select star from instructor means give me all of the fields in that table for every instructor. Now, you can include arithmetic operators in your select statement. So one of the fields for the instructor is an annual salary. So let's say we wanted to show the monthly salary instead. So we could say select ID, comma name, comma salary divided by 12 from instructor. That takes the annual salary and divides it by 12, and it gives us a monthly salary. Okay, let's take a look at a couple of select statements that we can do in our SQLite database. And I encourage you to have your SQLite database fired up so that you can follow along here. So here's our tables, and I'm going to do select. Well, I'm going to do something else. I'm going to do dot header on, and that'll give me a list of headers or field names at the top of my list. And I'm going to say dot mode columns, and this will put my results in a neat column. So it'll make it into a nice tabular format. Then I'm going to say select star from student. You always, in SQLite, put a semicolon at the end of your statement, of your SQL statement, not your administrative statements that you have with the dot operator. So, now we can see this is the results, and it's all of the fields for all of the students. And we can see their ID numbers, their names, the departments they're in, and the total credits they have. Next, let's just select one of the columns. Let's just select the ID column from student. So I will say select ID from student. Well, you know what? I'm going to do dot shell, and I'll clear the screen. That way it'll be better for you to see. So again, I just want to select the ID field from student. Semicolon at the end of our select. This time, the only field or column or attribute that's returned is ID. None of the others are. I can specify multiple columns if I want. So this time I'll say select ID, and let's say we want department name, or let's say name from student. So again, I'm selecting my attributes, ID and name, from the table student. And this time I pick up those two attributes from the table. Okay, and let's go back to the lecture. So, again, the syntax that we use is select and then a column list from, and then we give a list of tables. Now we're just going to be using one like we did student. And then optionally you can put in a where condition. So it's in brackets because that's optional. And the where condition will then not give you all the rows, it will give you only the rows that meet a certain condition. So this time let's take a look at our instructor table, and let's find instructors with a salary greater than $50,000. So I'll do dot shell CLS, and that'll clear my screen. Then I'll do, let's do a select statement from instructor without a filter. So select star from instructor, and here's all of the people that are instructors in our university. Now let's put that where condition in. We want where salary is greater than $50,000. So I will then say select, well, let's clear it. Now I'll say select star from instructor where salary greater than 50,000. Now I have many fewer, well, I have a few fewer instructors. Let's say we can change it and let's do 70,000. So find these instructors where their salary is greater than 70. So we get even fewer. And I can say, well, let's say even 90,000. And I get even fewer still. So we're filtering the rows or records that are returned to us by using the where clause in our select statement. So we've got the where clause, and we can use logical operators in our where clause. So we can have the relation salary greater than 80,000, and we can add other relations in there. For example, they have to be in the computer science department. If we want to find all the instructors in computer science with a salary greater than 80,000, we would say select name from instructor where department name equals computer science, and So the and connects these different relational filters together. So department is equal to computer science and salary is greater than 80,000. So let's take a quick look at that one. So select name from instructor. Oops. And we can go down to the next line where department name equals comp dot sci dot and salary greater than 81, oops, 1, 2, 3. Then we put our semicolon. That tells the compiler that we're done. And we pick up the name of Brant. So this is using an AND logical operator to connect two different relational comparisons. Okay, and of course we just did that one. Find the instructors in computer science department with a salary greater than 80,000. So we've talked about the select and the attribute list that we want. Let's take a closer look at the from clause. Go into a little more detail. The from clause lists the tables that are involved in the query. So if we want to find all instructors, for example, we would type in select star from instructor. Okay, so let's review our university database again. Here's the schema, and that's what we would use to review the database. And in it, we've got departments. For example, computer science and physics and finance and the various departments in the university. And we have a table of those departments. And each row is a department, and we have a row for every department in our university. Likewise, we have a table of students, and every row is a unique student, and we have, of course, all the students in the university. Same thing with instructors. We have a list of courses that we teach. And we have a section, list of sections, and these are courses that are being taught this semester. And we have classrooms, and these are the particular buildings and classroom numbers where the particular section is being taught. And then we have assignments where an instructor is assigned to teach a particular section. And then we have a takes or registration where a student registers or takes a particular class during the semester. Okay, let's go ahead and do another select with student, and we'll go ahead and look for total credits greater than 90. So I'll clear out the old, and we'll say select star from student as S, where total credits is greater than 90. And I put that as S because when we start doing operations with more than one table, we often have to qualify a field that we want with the table name. So rather than have to type out student, student, student all over the place, I rename, in the from clause, I can set an alias for student. In this case, I've set that alias as S. So then I only have to say where SID equals the section underscore ID. So it saves me some typing. And here, of course, again, we're applying a filter. This is not all the students. Let's look at all the students. So we have a long list of students. The ones who have a total credits greater than 90, in other words, they're seniors, we only have 4. And we see them listed here. And their departments are computer science, finance, electrical engineering, and biology. So there, pardon me, there's some special operators we can use in our where clause. And between is where you're looking for a value in a range. So you want to have where salary between 50 and 8, or but between two numbers. Is null checks whether an attribute has an empty value. In other words, no value was put into it. And then you have a like, and that gives you the ability, you don't have to get an exact match. It can be a partial match, and then you use a wildcard operator. And in SQL, the wildcard operator is not the asterisk as it is in many different search systems. In SQL, the wildcard character is the percentage sign. So let's find the instructors whose name starts with E. And of course, the structure of that is going to be where name like E percentage sign. So we'll clear this, .shell CLS, select star from instructor where name like E percentage sign. And here we get two individuals, Einstein in physics and El Sayed in history. And you can see that both their names start with the letter E. And we can also sort the results that we get. And to do a sort, we use the SQL phrase order by. So order by clause is used when sort order is important. So it's optional, so it's in brackets. So we select column list from table list, where condition list, order by a column list. So we can have one or more columns, and we can designate ascending or descending sort order in order to do our sorting. Okay, let's take a look at this where we get our instructors and we want them organized or sorted by department name. So we'll clear off the old query, .shell CLS or CLER, depending on the operating system you're using. And we'll type in our query here, select star from instructor order by department name. So now, if you look in the department name field, you can see we've organized our instructors by department. And we have Crick because he's first, because not because of his last name, but because of the department name, biology. And then we have Srinivasan, Kotz, and Brandt, all in computer science. Kim in electrical engineering, Wu, Singh in finance, El Sayed and Calafieri in history, and so on. A lot of times we'll want to we'll want to do calculations on the results that are returned to us. So SQL provides us with aggregate functions, and these aggregate functions are a built-in way for us to get typical types of mathematical operations we want, like the average of something, or the min or the max of something, the sum of something, or a count. So you want a count of the number of people in the department, or you want the sum of their salaries. So we can use that to get these aggregations. So, for an example, if we wanted to find the average salary of instructors in the computer science department, we would say select, and then we'd use our aggregate function average, AVG. Then we'd say what we want the average of, salary, and we put that in parentheses. So that's our select clause from instructor, where department name equals computer science. So let's go ahead and take a look at these types of operations. We'll get a count of the number of instructors, then we'll get the average salary we pay to our instructors, then we'll get the total salary budget for our instructors. We'll find out who makes the smallest salary, and we'll find out who makes the largest salary. So let's select count star from instructor. So we have 12 instructors in our university. Next, and I can hit the up arrow key so I don't have to keep typing everything. And I save myself some wear and tear. I'm going to do AVG salary. So I'll get the average salary that we pay our instructors. And so that's $74,833, roughly $75,000. Now, what's the sum of all of our salaries that we pay? In other words, how much money does the university have to put out every year for instructor salaries? Well, instead of using the aggregate function average on salary, now I'm going to use the aggregate function sum on salary. So we pay out almost $900,000 a year in salary to our instructors. And we see that as 898,000. So 898,000 is what we pay. Let's find out who makes the smallest salary. So instead of the sum aggregate function, I'll use the min aggregate function, and we get $40,000. And I can come back here. We find out that it's Mozart who makes that small salary. Next, let's find out who makes the largest salary. So I'm going to say select name, comma, max salary from instructor. And Einstein makes the highest salary at the university of $95,000. Okay, let's go back to the lecture. Many times we want to find out the average or some aggregate function for each entity type or each category. So for example, we might want to know the average salary of instructors by department. So what we were looking at before is the average salary for the entire university. If we want to get the average salary by department, we use the group by clause. So we would say select department name, average salary from instructor, group by department name. So what this does, the group by, is it will sort your table by the group by field. So it's going to sort it by department name, and then it puts in a control break. In other words, whenever the value of department name changes, like it goes from biology to computer science, you compute the average, or you compute the aggregate function. In this case, it's average. And then we are in computer science for a while, and then when we get a control break between computer science and engineering, we compute the average. And we start putting those average salaries in this table that we're going to return to the user, us, as a result table. So the general syntax then is we can do a select column list from table list, where condition list. We can do a group by if we want to do a grouping. In other words, we want to get an aggregate function for each one of our particular categories. We'll go over halving shortly, but that is basically where we filter on the group by. So a where filters on the table list, a halving filters on an aggregate function. And of course, we've already gone over order by, where we just want to sort the records. So let's give an example, and in this example we want to get the average salary by department. So of course we know we've got department name and salary in our instructor table, so we'll get those. Select department name, comma, average salary from instructor, group by department name. So let's take a look, and I'll clear this out. So we'll say select department name, comma, average salary from instructor, group by department name. So the semicolon tells SQLite that I'm finished. I could keep putting stuff on other lines, and then when I'm finally finished, I put in my semicolon and it'll run the operation. So here we have the average salary by department, and we can see that music has the lowest average salary. Okay, let's take a look at the having clause. Now, the where clause is going to filter out records we select from a table. After we run an aggregate function, we may want to filter based on the results of that aggregate function. So let's say we run an aggregate function of average salary. So we may want to say, well, we want to find the average salaries of all departments whose average salary is greater than $42,000. Here's where we would use a having clause. A having clause lets us put a filter on that temporary table we're producing that's going to give us average salary, the result of our aggregate function. So, the answer to this particular problem is going to be, so the question again is find the names and average salaries of all departments whose average salary is greater than 42,000. So we say select department name, comma, average salary from instructor, group by department name, and we've done that, and that'll give us the list of all the departments and their average salaries. But we want to filter that result, and so we're going to say having our aggregate function, in this case having average salary greater than 42,000. So a having clause is an extension of the group by feature. It's applied to the output of a group by operation. And it's used in conjunction with the group by clause. And it's similar to what a where clause does in the select statement, except the the having clause works with the aggregate function in a group by. So let's find the departments that have an average salary greater than 79,000. So we'll go ahead and clear this, and we'll say select department name, comma, and, AVG salary from instructor group by department name having average salary greater than 79,000. So now our output has been filtered, and instead of showing all of the departments grouped by department and the average salary for all of them, we're only going to show the results if their average salary is greater than 79,000. And of course that's what we have in this one. Okay, then I'm going to type in .quit, and that is going to exit out of SQLite. So, next is the homework. And just as a reminder, send me your answers using Sakai messaging. So, you have 5 queries that I have in the homework, and they follow this particular set of instructions. Select 4 of them that you want to work on, and send me the SQL queries for those 4. Each answer is worth 25 points. Naturally, partial credit will be given, so send me something for each one. And then, again, send me your results using Sakai messaging. The due date is in the schedule section of the syllabus. And here's the first one. Find the name and department of all seniors. In other words, if their total credits is greater than 90, and sort the result in department and then name order. Find the names and maximum total credits of all departments whose maximum total credits is greater than 105. Find all instructors in the computer science department with a salary greater than 80,000. List in alphabetical order all of the instructors. And then finally, find all instructor IDs find all course IDs taken in the spring 2010 semester. Okay, thank you.